Hello and welcome back. Today I have three process calibrators from the brand FNIRSI. One of them is sent to me for free, the other two are my own. These devices were originally designed as a process calibrator. Sometimes they even called loop calibrators, but FNIRSI here calls them signal generators. I think it's kind of a debugging tool that you can use on the big production line in factories. And the PLC or the sequence controller or any controller communicates with all the sensors and switches that are around. And they communicate just over voltage with 0 to 10 volts, or they communicate with current, because of course you have a little voltage drop on long wires, and then sometimes a current loop is more, just more reliable. So instead of 0 to 10 volt, I started to use between 0 and 20 milliamps. And then others said, yeah, but what if a sensor breaks or there is a break in my cable? Then I said, okay, yeah, maybe then between 4 and 24 milliamps. So that is usually what I can do. But there are also more modern, more advanced process calibrators that can also emulate resistance, sometimes between 20 and 400 ohms. And if you have, well, the LBO2 where you can do a little bit more, I think up to 2K. And some of them even have a little signal generator inside that generates also square waves up to a few K. And the more advanced, because of course, this is already analog age now, 0 to 10 volts, 4 to 24 milliamps. And later they had the digital, and that was Modbus. So some even have that. But more and more in the hobby community, they also find out it's actually a very versatile device. It can do voltage, can do current, some can do resistance, and there is a little signal generator. I can use this to calibrate my multimeter. This is about 4 years old. Strange enough, they use the same type number. This is the SG-003A. This is also the SG-003A. Be careful loading the firmware. It is not compatible. The one on the website is for the new version. And this is the one they sent me. It's the SG-004A. Very quick difference between them is the accuracy. This one is more accurate, and they have resistance added also. Well, clearly the marketing and design department did a good job. This looks all very, very simple. It also came with this, and I think it was just a simple brown box, and this is what it looks like now. Nice with the manual. The generator is a bit bigger, which is good. In production environments you need something bigger than this tiny thing. And it comes with all the plugs, which is great. The two blue ones, almost similar specifications. The accuracy is the same. It is 0.1% plus added a few digits on the end. And the yellow one here is a lot better with 0.02%. Also added a few digits in the end. Let's have a quick look at the improvements of the user interface. Switch this one on, switch this one on. Here we can see it's quite simple build up, but there is a 4-year difference, and also there is an extra digit here. While the accuracy is the same, maybe the ADC has a higher resolution, I don't know, but at least we can play with its extra digit there. The user interface you need to get used to, but once you know, it's actually quite simple. Because it is a process calibrator / the process debugging tool, it is not only to generate a signal, but also to read back a signal. So it's kind of a low resolution voltage meter also, which can read current, resistance, depending of course on your model. And the cool thing is with these modern displays that you can do of course a lot of stuff. So if you're reading back a signal, here you have kind of a mini scope. Another improvement I did hardware-wise is that they have other terminals. These are just the standard bananas, which is of course great, because here you needed to have these special small ones. If we look at it technically, because this one is only 0.1% and it comes calibrated, but they built in something that you can recalibrate it yourself, which is great. This possibility I have not found in the older type, and it's available in both of them. So if you are planning to use it for multimeter calibration, maybe you can recalibrate it on a 6.5 multimeter, but still this one is 0.1%, this one is 0.02%. So using it as a calibrator, maybe for 3.5 digit, this one maybe 3200 counts, and this one maybe 6000 counts, because it is actually not made for it, but you can do at least your basic tests. Let's have a closer look at the user interface. Like I said, you need to get used to it a bit, but in the end it makes sense, because you need to tell it, are we a generator or are we a multimeter? And if you start pushing around, you probably don't. Well, now you see, okay, the digit goes up and down. Here I can move my digit, that's good. But how do I change function? Because what function are we now? The font is a bit small. I wouldn't mind if they did a lot less digit all around, and then just make the font a little bit bigger, but it says voltage output. But if you start pushing, then, well, we've seen, okay, this moves the cursor, this is on off, that makes sense. That you switch the output on and off, and then you have the function button, and then we can do something to convert, or presets, or, well, the curves we have seen. And, well, for me it was confusing, I didn't get anything out of it. And then you find out, okay, what do I want? Do I want to set the output? And then you do function out, and then here you come into a setting menu, and if you change the settings or not, this also changed the function. So if I go to frequency here, and I don't change anything, I just go out, then we are now in the frequency mode. So it's not only a setting menu, this is actually the function menu as well. And here we can do in actual values, or in percentage, or you can set some limits here. What else we can do? We can set here also ranges if we do something automatic. Here we can do some programming, and here we have presets, that is underneath one of these buttons. And here we have the calibrator. We can set calibration points. And this is a nice extra. You can make that a lot better by calibrating it. And here we have different voltage points which you can set. So we can just change these values. I didn't do that yet, of course. And here you can set up and down. You compare this to a better emitter, and then it should be better, or it's maybe good enough. Let's first check how good it is. So this is how it works. And if we look at the more luxury one, of course we have a lot more options there. So I go out to out, then it's just very simple. You set it to 1 volt and you want the output on, and that is exactly what's going to happen. If we look at this one, I didn't get the backlight much brighter than this, so it seems that the yellow one is less bright. But if we go here to the output, we have a lot more options. We have the milliamps, we have the voltage. This is, I think you have something to convert. You can read the voltage and then output the current, or the other way around. Or you can read in a frequency, and then based on that frequency you can export a certain voltage. So it's quite advanced. Here we have, I think, frequency. Here we have millivolts. That's extra on this one. And you can read a lot of thermocouples as well. The 24 volts, I think. And we have here the ohms resistance, which is great. And I think you can even set an offset. We can set maximum ranges. You can program also, and I think you can calibrate it as well. This resistor option, of course, is extra only on the 004. So what I like to do now is do some basic accuracy testing, and I I just have a few voltages. I want to test 1, 2, 5, 10, 15, 20 if it's possible on that model, and with the current 1, 4, 10, 15, 20 milliamps, and later the ones that have resistance. I'm just picking a few points that seem reasonable, and then we can see it before calibration and after calibration. And of course, what is interesting for me is the new one so much better before calibration? This one cannot be calibrated, but this one can be. So what I will do, I will just write down what I found. So I'm checking first the 1 volt, and then I'm checking how much that is on the meter here. So the rest I will do in time lapse, but to explain, if it would 1% in a value of 1, that means it should be between 0.999 and 1001, but the last digits here 005, so that added to it is exactly this 1 volt. So in that sense it is good. You can see also on the multimeter why it is limited to this, why I think it is limited to this 3.5 3200 counts, because you see the stability, it jumps a little bit, but that's okay, because they also said it would be within this 0.1% plus and minus the 5 digits on this precision, so it is actually exactly within. So after 3-4 years, is it still within spec? Well, this is almost spot on. This one is, here it is a bit tight. Here we have 85 as the lowest, but 87 is good. And that is only the 0.1%, so we still have the 5 there. This one is out of spec, the 1 milliamp, because the maximum would be this one plus 5 would be 6, and it is 7. So that one is off, but this one plus 5 should be 9, so this one is also just a little off. Here we are also with 1, we are a little bit off. Here we are good. Here we are also fractional off. Adding the 5 there would be 25. So the current is a fractional high. Looking at that 20 milliamps, that is here a little bit too high according to this meter. Is according to my fluke, it's just good, because this one also has plus or minus the last digit, and if we go to 15, that was also a little bit too high. You see, this one agrees because it is also this last digit, and if we go to 10, it is exactly 10 even, and the 4, that was a little bit too high, is even very good. And this is a great example that you can use this for 3.5 multimeter 3200, because this one has a digit more or less. This one has even the 5, the last 5 more or less. And you can perfectly check or verify your simple multimeters with this device, but clearly, of course, it is not for 6.5. Now I like to see how good is this one out of the box. It should be exactly the same, this 0.1% plus a few last digits. And this one is actually showing a digit extra compared to the other one. So let's see. So we'll be doing exactly the same. We want to switch to output, set it to voltage. Okay, back. Now we are set to voltage. I start with 1 volt output on, and let's write down the numbers. Here we can also see that for a 6.5 it is just going a little bit down, and then it's correcting itself. It's going up and it's going down, but as long as this one doesn't hit the 5, it is within specs. What I see with the voltage is that it's actually perfect. It is well within the specifications. Just 3, 1, 2, 3, 4, 7. And 7 is still good, because look at this, we can all the way to 0 to 0, and we are here at 007. That's good. The current is a fractional low, to be honest, because even here we should be then at 5. It's 9.4, and it is 9.0. Here we are just about good. Here we are good. Here we are good, here we are good. So in the lower, it is a fractional too low, but again, we probably don't see that on our 3.5 meter. Well, we actually can see it on this multimeter. Here it is a bit low, and here it is a bit low, but again, this multimeter also has plus and 1 digit. So out of the box, the current was not spot on, while the voltage was, and it is even outside specs. So what we're going to do, we're going to see if this calibration procedure works and if you can get it within specs. So calibrating it ourselves did make it better. The only thing is it should have been within specs out of the box, so that is a pity, but this is the lower model. Let's see if the higher model does better. So this one is probably calibrated better and has a better ADC inside to generate a more precise voltage, because here they specify instead of the 0.1 we have here a 0.02. So that means it should be within this, but then of course added this digit, and instead of a 5 it is a 3 now. So I will be doing exactly the same, writing down the values that I see on my GW stack. I need to go to the voltage right here, and I write it down. Okay, that is good news. The SG-004A is actually better than the 003A. Every value I measured was within specifications, and even the voltage and the current was spot on. I also did the millivolt and the resistance. There I found a little bit more deviation, but that is correct. They specified also a little bit less accuracy there. So it is all spot on, and it's cool. This one can do resistance and the millivolts that the other one does not have. Here we have the results. You can see this is within, because we have here the 003, then it's exactly rounded. This one was really spot on. The 5 volt, the 10 volt, the 15 volts, the 20 volts. Look at this. And here we have again that a little 3 there. The millivolts was a little bit more with the 009, and it should be a 3, but this one added is a 6, but we can add not the 003, but we add 03. So then it is false exactly here, and then it's enough. Here it's correct, here it's correct. Then we have the milliamps. Well, they were again very good. The resistance is also good. Look here, we have the 0.2, but here it is plus 1, so that makes it exactly. We can get it a little bit higher with calibration, but the point is it is within specs out of the box. Here too, here too. There was one a little bit weird thing. I'm now measuring the ohms. I'm now in the millivolt mode, so the impedance here is 1.5 meg. If we go to voltage, it's about the same. In the translation also, in the hertz also, millivolts here, we go to 60 ohms, 24 volts, it's again the 1.5 meg. But if we go to the ohms, and that surprised me, no matter it's switched on or switched off, it is always this 1 ohm. That is a bit weird, because if I say now 10 ohms and I switch it on, then it nicely goes to the 10 as expected. but when I switch it off, I expect actually open, and it's not open, or this 1.5 meg. It's actually 1 ohm when it is off. That is a little bit weird, I think, because if I set it to 300 ohms, it nicely does that, but switching off, you expect open and not 1 ohm. That's something you really need to think about. Let's try the same on the fluke here. Well, we have the same. Now it's set to 300, but I've set it to open. Here it also thinks it's 1.1 ohm. And then, of course, when I set it to 300, this one also is fractional low, by the way, exactly what I measured on the GW Instack here. I measured 100, and 100 was 0.68. Well, here we have 9. It is interesting to see how it is trying to stabilize itself. Then it is 5, then it goes fractionally below, and then it notices it is too low, it goes up, it goes down, and constantly adjusting itself. And it actually works good, because doing that it stays within specifications. But it is just, you can see it is not a real calibrator, because it's also not designed for that purpose. It's really a debugging device for processors. And then it is possible to upgrade the firmware. There is one thing that I need to warn you. So I went through the menu to see if I can find somewhere an info screen on what version this device is actually running, and I could not find it. And I asked FNIRSI also, where can I see what firmware I'm running, and you can't. So when you look in the website, you are not sure if your version is newer or older. Also, it didn't say in the start screen. While in the newer one, the 004, I will zoom in, you can see slightly in the bottom, when you start, you see here 3.0. So here, that is probably the firmware, or it's the hardware version, I'm also not sure about that. But when I look on the website, you see version 2.11. So before you do an upgrade, I think you need to be very sure what version you are running now, and I can simply not see that on this one. So I will not do a firmware update, because maybe I do a downgrade, and for this one it's the same. Well, I think it is probably version 3.0, because this one is new, sent directly to me by the factory. But on the website I see still version 2.11. So that is for me too risky, and that is a pity, because a lot of these upcoming Chinese companies just don't have their website in order. And I really say it's a pity, and I mean that, because they do a lot of work in development, that even these cheaper devices, they actually have regular firmware updates. And well, this product is a little bit more expensive, so you would expect maybe a little bit better. But you see that also from the SOG and the FNIRSI, that they do updates, but it's not always there on the website. You just find it out by you order a new device, and suddenly it's a 3.0 like this, while on the website is still. There are some more tricks with the USB. If you keep the device switched off, you connect the cable first, you hear a sound, plung, and then it starts charging. But if you then switch it on, it opens the USB drive where you can put in then your firmware. But if you do it the other way around, you switch on the device first, then you connect the USB cable, it creates a COM port, and it's a COM 8, 9, depending on what other COM ports you have on your computer. And it's very unclear. They just say, yeah, it creates an analog serial connection, but it is not explained what you can actually do with that serial port. So I tried to connect my terminal program, tried different bound rates, but I couldn't get any data out of it. So maybe someone knows, it would be nice. It's not explained at all in the manual. So please let me know then in the comments. So that's it. I realize I only tested it as kind of a multimeter calibrator validator for after you did your repair or your cleanup, that you can just quickly check if the failures are good. 3.5 digit, 6,000 counts maybe, especially with the yellow one with the 004G. It was calibrated out of the box with, within the specs, so that was actually good. Thank you for watching, and hope to see you next time.